All right, hello everybody. We are going to continue on with the section that we started on how to graph sine and cosine waves. Very brief review. The big thing that you want to get from the last lesson is that if you are graphing the sine wave, you want to be very familiar and kind of have memorized what the shape of that wave looks like. Okay, we know that it starts out going up as a small hill and ends as a small valley. The other really big takeaway is the fact that the sine wave always crosses the midline at the beginning, at the middle, and at the end of the period or cycle. Okay, I use those location words beginning, middle, and end because today our values that we're going to label along the x-axis are no longer going to be 0, 90, 180, 270, and 360. So I don't want you to memorize that the sine wave crosses at 0, 180, and 360, but rather beginning, middle, and end. Okay. We also learned that the parent function for the cosine wave takes on the shape of one very big valley if it's not being flipped over the midline. And we want to be familiar with the fact that if it's the cosine wave, that is crossing the midline at the 1/4 and 3/4 mark through the period. Okay. So the things that we had discussed so far were what happens when in front of your trig function you are multiplying by a number. We called that the amplitude. We said that represents half the height of the wave. And if it happens to be negative, then that means your wave is flipped. So the sine wave, if the a value is negative, would kind of be flipped the other direction, or the cosine wave would then be a big hill instead of a big valley. The other thing we discussed in the last section is what happens if you add or subtract a number all the way on the outside of your trig function. We know that that's technically causing a vertical shift in your graph, but we called that where you would place the midline. Okay. The thing about A and D in these equations is those are things that are occurring on the outside of the parent function. So those are things that are going to affect your graph somehow vertically. Okay. What we're going to look at today is we're going to look at what happens when you throw numbers on the inside of the trig function. So in other words, in the parentheses there, how is that going to affect the graph? And of course, we know from studying transformations this year that when you make changes on the inside of your equation, now you're going to be affecting your graph in a horizontal fashion. And so that's why we're going to see things like maybe instead of the sine wave starting over here at 0, maybe we're shifting the graph so it starts maybe at, say, negative 90 degrees, and so it's been shifted to the left. Or maybe we're stretching it horizontally, so instead of where it normally would go through one cycle in 360 degrees, maybe if we stretched it, it would take maybe 720 degrees to get through one cycle. Or if we shrunk it, maybe it could get through one cycle in just 180 degrees. Okay. So I want to start, first of all, before I introduce what we call period length and phase shift, which affect the graph horizontally, I'd like to start with the example down at the bottom and at least answer the parts to that question that we know from the previous lesson. Okay, so of course I know we've got some extra numbers in the parentheses here that we're not used to, but let's just ignore that for the time being. And you'll notice in our box over here, we usually only had 3 blanks, and now we have, kind of 2 extra ones here that we'll address here today. But let's answer at least the 3 blanks that we're comfortable with. Okay, we know that the midline is any number that is added or subtracted all the way on the end. So in this problem, the midline would be at -1. So if we wanted to, we could go ahead and kind of at least set up that we know on the graph. I'm going to label -1. I'm going to put that dotted midline down there, so my wave is going to be shifted down 1 unit. Okay, the amplitude, we know the amplitude, we should always write the amplitude as a positive number. So if you notice that the number in front of your trig function happens to be negative, Don't address the negative in the amplitude part. The negative has to do with the fact that when you answer this question, is it flipped? You're then going to say, oh yes, this is definitely going to be flipped in the opposite direction that we're used to the cosine wave being. Remember up here with the parent graph, it's normally this deep valley. Well, we're going to expect this wave to take on the shape of kind of a big hill instead. Okay, so I'm going to go ahead, since I know the amplitude is 3, that means I need to allow myself enough room on the y-axis to stretch up 3 units from the midline. Okay, you guys catching that? I don't need to mark up here to 3. I need to make sure that if my midline is at -1, that I can stretch up counting 1, 2, 3 units above, and then also I'm going to extend this here 3 units below the midline. So this is me just kind of setting up the problem. Okay. Now, the issue is I'm not exactly sure where this wave starts, because before we would always say that it started at 0 degrees, but now you can see that there's been some horizontal shifting taking place. So we're going to learn a couple new phrases here today. A horizontal shift, and I'm going to start with phase shift here first. That's the term that means you're starting your wave either a little bit to the left or a little bit to the right. Phase shift. The phase shift, in essence, is where your wave begins. Okay, there's a strategy that we're going to use for how to find the phase shift. All the problems you're going to be asked to do tonight on your homework are all going to be degree problems. We're going to save the radian problems on this notes page for a video for tomorrow, okay? And we'll save those radian problems on your worksheet for tomorrow. So for tonight, what you're going to do to get, okay, where does this wave start? Is it starting to the left? Is it starting to the right of 0? What you're going to do is you're going to grab the bx plus c portion. Okay, that's what's in the parentheses after either the sine or the cosine. And you're going to place that, and I'm going to do this work off to the side here. You're going to place that between 0 and 360 degrees. So you're going to look back at your equation. I see that I have 2x plus 90. I'm going to put that in the middle here. And what your goal is your goal is to solve this inequality so that you're getting the x by itself in this middle section here. Okay, so this looks a little weird because we have like a couple less than signs here, but you have 3 sections to this inequality, and you're just going to use algebra to try to get the x in the middle by itself. So for example, the first thing we would want to remove from the middle would be the plus 90. We're going to subtract 90. Kind of treat this like an equation though. Whatever you do to the middle section to get rid of that 90, you need to do that same mathematical operation to the other ends of the inequality. Okay, so you're going to subtract 90 from the left side. So 0 minus 90, that now makes that negative 90. Now in the middle, I only have 2x because I got rid of the 90. And then we are taking 360 minus 90 on the right side. That gives us 270. Okay. Now, mind you, we still don't have the x in the middle by itself, but we're really close. Okay, the next thing we want to do to get rid of the 2 is we would now divide the middle section by 2. So I would want to do that same thing with these other pieces here. So that leaves me now with dividing the negative 90 by 2 and the 270 by 2. So now I have negative 45 on the left and 135 on the right. It is this negative 45 that is your phase shift, okay? This number right there, I'm going to put that right on my blank. This is where your wave is actually going to start. So I can see that on my graph, I'm going to need to extend my x-axis out to the left a little bit, and I'm going to go ahead and mark off that I know this wave is going to begin at negative 45 degrees. Okay, now here's what we know. We know that the phase shift, I'm going to write down, this is where the wave begins. This 135 is where, oops, I didn't write wave there, where the wave ends. Okay, now be very careful. Period length is not where the wave ends, okay? But I do need to know where the wave ends, so I'm going to come all the way over here. I'm just going to kind of spitball here and say that it looks like maybe 135 falls right about there. Okay, we will talk about period length here in just a moment. Okay, so I know where the wave starts, -45. I know where it ends, 135. We always have to always label the 5 critical values, okay, on the x-axis. Okay, so I now need to figure out, well, where would be the middle of this wave? Well, think about it. If you want the middle of two numbers, all you have to do is average those two numbers together. So on your calculator, you're going to add together -45 and 135, and you're going to divide that by 2. Okay, you're going to divide that by 2. Oh my goodness, I keep messing this up. Okay, and that gives you that the middle of this period is 45. Okay, we also need to label the 1/4 and the 3/4 mark. So think about that. The 1/4 mark would be the middle of the beginning and the middle. Okay, so I want to average these two numbers. So if I were to average those two numbers, I would be adding those two numbers together and dividing by 2. I'm going to get 0 divided by 2. So I know the 1/4 mark is at 0 degrees. Okay, and then I have to have labeled the 3/4 mark, which would be me adding together these two numbers, 45 and 135. I would average those, so I want to divide by 2. That gives me 90 degrees there. Okay, once you have those labeled, I think we're in a pretty good position to go ahead and try to sketch this. Okay, take note, this is the wave you're sketching, the cosine wave. We said at the beginning, the cosine wave crosses the midline at the 1/4 and 3/4 mark. Now, look at where your midline is. It's down here at -1, only this time the 1/4 mark is at 0. Hey, I lost my 90 degrees here. The 1/4 mark is at 0 and the 3/4 mark is at 90. So you're going to put a point on the midline at those two locations. Also, we said, oh yeah, this is flipped. So instead of at the beginning of the wave, which is now at 45, instead of starting up and making this big valley, you're going to start down. Okay, and remember, you stretch down whatever your midline is. So, or I'm sorry, your amplitude. So from the midline, you're going to count down 3 units at -4. In the very middle, which is at 45 degrees, you're going to stretch up 3 units, and at the end, you're going to go down 3 units again, okay? And we're going to connect that. Now, I have not answered the period length. The period length is how long or how many degrees does that wave span? And here's the formula. You want to take where the wave ends, which is 135, and subtract from that where the wave begins. So I get a double negative here. This wave has a length of 180 degrees. Starting at -45 and ending over here at 135, it spans 180 degrees. Note, that is not the same, period length is not the same thing as where the wave ends. Okay, we're going to try one more very quickly here. Okay, let's answer our questions. Midline, that's at 2. Amplitude, +2. Flipping, oh yeah, this one's going to be flipped because it's negative. Okay, I'm going to go ahead and mark off that the midline is going to be right up here at 2. I'm also going to label so I can stretch up 2 and down 2 from the midline. And now I'm going to work on my phase shift, which is me grabbing this 4x - 40. I'm going to put it between 0 and 360 degrees, and I'm just going to use algebra to get the x in the very middle by itself. Okay, whatever you do to the middle, you have to do that same thing to all 3 sections here. So you can kind of see what I'm doing here. I end up getting 10 degrees on the left, 100 degrees on the right. Okay, now remember, 10 degrees, that is my phase shift. So that tells me this wave is not starting at 0, it's starting at 10 degrees. Okay, also remember that this 100 is where the wave ends. I need that number when I label it on the x-axis over here. Okay, if I know where it starts and where it ends, I can easily just use an averaging technique to get the middle. So I'm going to add 100 and 10 together. I get 110. I divide by 2. I get 55 degrees. By the way, if these end up being decimals, no big deal. Okay, it's fine if it's a decimal. Now you're going to average 10 and 55. So you're going to take 65, divide by 2. That gives you the 1/4 mark. Here's a decimal, 135.5. And then to get the 3/4 mark, you're going to average 55 and 100. That means this gets labeled 77.5. Okay, so I'm looking at my wave. This is, again, a cosine wave. So I'm going to label on the midline at the 3/4 and 1/4 mark, that's where it's crossing. We said, yes, this is flipped, so I need to stretch from the midline down 2, then up 2, then down 2. So there's my wave. And finally, to answer the period length, I'm going to take where the wave ends minus where the wave begins. Remember, I'm getting these numbers from my inequality. I'm doing 100 minus 10. The length of that wave is 90 degrees, and it sure looks like that would be true. It's spanning 90 degrees there. Okay. Please reach out if you guys have